What's up, guys? Today I want to show you how to make a video game in Java. If you're in that beginner to intermediate range of learning how to program, and you're looking for a project that isn't super boring, you're in the right place. So this is an active tutorial. Don't just watch this video. I've designed this project specifically for you to write your own code and to make a video game that's all your own. If you're new here, my name's Ben, this is Learn Code by Gaming, and today we're actually making a video game. We'll be making a 2D game using the Java Swing library, and this project builds off the work we did in the Bob Ross Joy of Coding video. So if you get really confused as I start to go through this, or if you just need more practice with Java 2D graphics, then you should go back to that video and do that project first. My idea for this project was, there's certain things when developing a game that are just kind of difficult, but they're unavoidable. And I don't want to overwhelm you with things that you might not be ready for yet, that maybe are acting as a barrier to you having fun with code. So I thought I'd start you off with just like a template project, just a real simple game that gets you past some of those initial hurdles so that you can get to the fun parts. Now I'm not going to do a full code along this time, but I want you to get familiar with the code base that you'll be working with. So what I think we'll do is, in the first half of this video, I'll show you how I built up this code, so you can feel comfortable with it, even if you don't understand what every line does. And then in the second half, I want to give you some ideas and direction for where you can take your game. Sort of like little homework projects that can all add up to a game that's uniquely yours. And I'll break those ideas down from easiest to hardest so you can properly progress your skills as you work on your game. So if you're ready, the first thing you'll want to do is download this code off of GitHub, and then run it once to make sure that it's working, and then come back here and we'll talk through the code. You can either clone it if you're familiar with Git, or just download the zip file. Alright, so I'm going to explain this by showing you the process that I went through to come up with this code. So the code I have here doesn't look exactly like the code that you downloaded, but by the time that I get through this process, it will be. So the main app class is pretty straightforward. It's very similar to what we did in the Bob Ross project. We're just using a JFrame to create a window, and then our JPanel. Before, our custom JPanel class was called myCanvas, and here I've changed it to board for the game board. And then in the main method, I've got some boilerplate code here, but all you need to know is that when main's called, it'll call init window once. And in that Joy of Coding project, we had our myCanvas class in the same file as the rest of our project. But here I've taken that JPanel class that we called board, and I moved it over to its own file. So in here, again, it's pretty straightforward. In the constructor, we're setting the size of the JPanel and the background color. And then I'm also loading up an image that will represent our player character. And then I'm setting an X and Y value just as a location to draw that image for now. And the image loading code is just like how I showed you before. And in Paint Component, all we're going to do is draw that image on the canvas. And then I have an extra line here that's just going to smooth out some animations when we get to that step. And so when I run this, it does what you expect. We just have that 900 by 600 pixel canvas, and it draws our image at that XY location. So the next thing I wanted to do was to animate this image so that it moves across the canvas. And an animation is just an image that moves over time. So I created a timer object using the timer class, which is a part of the Java Swing library. And every so many milliseconds, it's going to call a special function for us. So I've set that delay to 25 milliseconds, and I've also implemented this action listener interface. And when you implement this interface, you need to create this action performed function. And this is the function that will then get called every 25 milliseconds by that timer object. So in here, I've decided that every 25 milliseconds, I'm going to increase the X and Y coordinates by 2 pixels. And then I'm going to call repaint, which will trigger our paint components method to be called again. And of course, in that paint components method, we're using that X and that Y value to draw the image. So when we run this program, every 25 milliseconds, it's moving over to the right and down by 2 pixels. And that gives us the effect of this animation of that image moving across the screen. All right, so now that I know how to move images across the canvas, the next step is I want to tie that to some keyboard inputs. To react to keyboard inputs, back in our main app class, I added a keyboard listener to our window, and I decided to pass in our gameboard object so that it can be the one that gets notified when there are keyboard inputs. So in the board class, it's now also implementing key listener. And when you do that, you need to define these 3 functions. And so whenever a keyboard key is pressed down, this key pressed function will run. And when it's released, this key released function will run. And then there's also this key typed method that you have to define, but we won't be using it. And you'll notice in key pressed, I decided to pass that event along to this player object that we haven't talked about yet. So previously, I showed you I had variables for the player image and also the X and Y coordinates for that player image. And I decided that stuff would be best kept over in its own class. So now we've got this player object that we initialize in the board constructor. And in paint component, I move that draw image behavior over to the player class as well. So let's take a look at that player class. As you can see, it now holds on to that player image. It also holds on to the player's XY position, but instead of having those as two separate int variables, I decided to use this point class, which does pretty much the same thing. It just keeps track of an XY coordinate. So in the player constructor, I'm just loading the image and I'm initializing its initial position to 0, 0. In the draw method, I'm just drawing the image using that image file and then the X and Y values from that position. And then we have this key pressed method. And remember, this gets called by the board object whenever it detects a key press. And in here, I'm just figuring out what key was pressed. So if the up arrow key was pressed, we'll go ahead and remove 10 from the Y position. So this will have the effect of moving our player up 10 pixels. And then so on for the right, down, and left. And so now, when I run the game, our character starts off in that upper left-hand corner. And then as I press the right arrow key, it moves over to the right. And the down arrow key will move it down. And so on. We've got movement. And if you've never done this sort of thing before, it's really satisfying to know that you wrote some code that when you press a key on the keyboard, you see instant changes on the screen. So yeah, this is pretty sweet. So now that we can move our character around on the screen with the keyboard, I decided I wanted to break our game out into a grid, like a checkerboard, because I think this will be easiest for you to work with and build off of. To do that, back in our board class, I created a tile size constant just to control how large our tiles are in pixels. And I also want to define our board size now in terms of how many rows and columns of tiles there are. So in the constructor, set preferred size when I'll set our JPanel size based off of those tile sizes and how many rows and columns. And in paint component, I added this call to draw background to draw that checkerboard pattern. And so I wrote this draw background method that just goes ahead and draws out all of those tiles. And it does that using fillRect, which you should be familiar with. And I also want our player to move one tile at a time. So previously, this position variable we were using to keep track of the pixel location of our player. But now I'm going to use it to keep track of the position of our player on the board instead. So right now it's at the 0, 0 position. But for example, 2 tiles to the right, I want that to be x equals 2 and y equals 0. So I updated the key pressed method. Instead of adding 10 pixels every time you use one of the arrow keys, it's now going to add or subtract just one position depending on what arrow key you pressed. And then in the draw method, we can figure out what pixel location to draw our player at from the X and Y position on the board just by multiplying that position by the tile size. And then I also don't want our character to be able to move entirely off of the board. So to fix that, I decided that in action performed, remember this is that method that's called every 25 milliseconds, I'm going to have it make a call to this new player method called tick. And then in this tick method that's going to get called once every tick of our game, I'm having it check the X and the Y of our player position. And if that player position is off the board, it's going to move it back on. So at this stage in the game, I can now move our player one position at a time. And then when I get to one of the edges, I can't move past it. Next, I decided that I wanted to add some sort of scoreboard. I'm keeping track of the score on the player object because in the future, who knows, maybe we might have multiple players. I initialized the score to 0. And then while I was developing this, I decided to just give the player 1 point every time they press one of the keys on the keyboard. And then I wrote this simple getScore method. And in the board class, inside of paint component, I'm calling drawScore. And this drawScore method is a little bit long. 1, because it took some work to get the text to draw nicely. And 2, because I wanted to center the text at the bottom of the canvas. but pretty much it just gets the score from the player object, and then it draws that string. So now, every time I move the character, my score increases by 1. You can see it's this green number at the bottom. And this is pretty cool, but there's no object to the game yet, so I want to add some coins for our player to pick up. So I created this coin class, which is very similar to the player class. Coins, of course, have their own image and their own position on the board. Load image, draw, and get position all work exactly the same, but coins don't need to react to keyboard inputs. In the player class, I won't be giving them 1 point every time they press a key anymore. Instead, I added this add score method to increase their score. And we'll use this to add some points to our player score every time they pick up a coin. Back in the board class, we have the player, of course, and now we also have an array of coins. And in the constructor, that array will be populated by this populate coins method. And in this populate coins method, it's using a random number generator to add a certain number of coins to the coins array in random locations. And I believe I've set this numCoins value to 5. And in paint components, I've got a simple loop that will draw each coin. So when we run this, we've got the background, we've got the player, and we've got the 5 coins in random locations. And I want the player to be able to pick up these coins. So in the actions performed method, remember this gets called once every 25 milliseconds by our timer. I've added this call to a new collect coins method. And I've defined that method to loop over all of the coins. And if the player's current position equals any of the coin positions, we'll go ahead and add 100 points to our player score. And then after we've checked all of the coins, we'll go ahead and remove those collected coins from the board. So this is the game you're starting with. We can move our character with the arrow keys on the keyboard. And when we walk over to one of these coins, we'll go ahead and collect it. Our score will go up by 100. And that coin is now removed from the board. So hopefully that helped, and you're feeling at least a little bit comfortable with the code. Now let's talk about some of the things you can do with this starter code to build out your own game. You can find these project ideas in the README file, and you're not meant to do all of these, just pick the things on the list that you like or that you want to try. And if you have any of your own ideas, definitely just go for it. This first set of beginner tasks might seem a little bit trivial, but doing them will help you get more comfortable moving around the code and modifying it. You can change the colors that are being used, for example, in the background. You can also swap out the image files that are being used, and these should be the same pixel dimensions as your tiles. You can change how many points you get per coin. And for those first 3 items in the list, instead of having them being hard-coded values, consider making them constants on a class like we do for the number of coins or the delay between ticks. You can change the player to use the WASD keys instead of the arrow keys for movement. Try changing the dimensions of the game board. Try making a new coin appear whenever the player picks one up. So you would be working in this collect coins method to do that. And the final one in this beginner section is to change the tile size. Just remember if you do that, you'll want to update your image files. Now in the intermediate section, these ones are a little more challenging and should help you develop your problem-solving skills a little bit more. So the first idea I had here is to make coins disappear after some time. So you could do that after so many ticks, or maybe using a separate timer, or even by counting how many squares a player has moved and making the coins disappear after that. You could also have new coins appear at random times. That checkerboard pattern that we drew in the background, you could replace that with an entire image. The player and the coin classes, you probably noticed, have a lot of things in common. So to get more practice with object-oriented programming, a good exercise would be to create a parent class that both of those classes extend from. Along those same lines, you could create a special coin that maybe extends from the coin class, and that special coin could maybe look different or be worth more points. Right now, we don't really have an end to our game, so one thing you could do is restart the game after all of the coins are collected, or after some score is reached. And when you decide what winning the game means, Another thing you could do is to add some sort of celebration graphic. You could add some sort of clock to the game, and you could have it replace the score or be a feature that's in addition to the score. And that would be something that you could display down at the bottom just like we do with the score. So maybe in your game, you see how many coins a player can collect within like 60 seconds. Something like that. Keep track of high scores. So the easy way to do this is just to create a variable, and every time a game ends, you just check to see if the new score is greater than the previous high score. But of course, this is just going to reset every time you close the game. So to make that persist, you'll want to write that high score to a file and then read it in the next time the program starts. And the last idea in this section is you could have the player actually wrap around the edges of your board instead of blocking them when they get to the edges. So for example, if your player is all the way over to the right, if they click right again, you could move their player all the way over to the left side of the screen. And this may sound a little tricky, but if you focus in here on this tick method of the player class, it's really just some minor updates you need to do to the logic here. So if you can get through some of those tasks without much problem, here are some more difficult ideas to try. You could add obstacles to the game board to block player movement. You could add a new object type that reduces your score when touched, or maybe it ends the game. So this would be similar to a coin, but a bad coin. You could make an object that moves around all on its own. So this could be something like a ghost from Pac-Man, or you could just have the coins themselves move around the board. Add sounds to your game. So some ideas for that are add a sound when your player moves or when they pick up coins. You could add a constant music track to the background. Or you could have a special sound that plays when you first open up the game. You could modify your player movement code to only allow players to move one tile per tick. So as the game is, you'll notice some odd behavior if you, for example, hold down one of the arrow keys. On Windows here, your player will move one square, and then it'll pause for a moment, and then it'll start moving in that same line really quickly. Also, if you try to press two arrow keys at the same time to do a diagonal movement, right now the game doesn't respond very well to that. So the solution to this is in your player key pressed method. Instead of immediately changing the character's position here, you could keep track of just what direction the character wants to move in. And then in the tick method, you could actually perform that change to the player's position. And if you do this, you'll also want to listen to the key released event, as this will let you know that the player no longer wants to move in that particular direction. Alright, what's this next one? Make the total game area larger than the portion of the grid that we see in the game window. So right now, this grid is our entire world inside the game. But you can imagine this world expanding to the left, to the right, up and down from what we see in our window. So in that sort of game, our J panel would just be the viewport that our player has into the world. And so maybe that viewport moves as the player gets closer to one of the edges. Or maybe that player stays in a fixed position, and every time the player hits an arrow key, it's actually the whole viewport that moves with the player. Think about the other keyboard keys and what sort of actions those might perform. So it could be something simple like you press shift and the colors in the game change. Or if you've done some of the previous tasks and you have the concept of health in your game, maybe you've got some health potions and your player can restore some health by pressing Q. Things like that. Add more scoreboard or HUD elements. So right now we just have that score at the bottom of the screen, but maybe there's some more information that you want to show to your player. And I took the easy route of just drawing this right on top of the background, but maybe you want to have some designated area for this sort of information. So you could add some graphics like that to your board. And finally, you could eliminate the grid concept altogether and just use pixel positions instead. So I added this checkerboard grid just to make some of the concepts easier. But remember, pixels work exactly the same way, it's just a giant grid. So if you can wrap your head around that, you can obviously do some pretty cool things with this higher resolution. And if you get through all that and you're still looking for more, I found this really good resource that's all about making these sorts of Java 2D games. So check out this link in the README. And I'm not familiar with this guy at all, but this was a really great resource for me as I was developing this project. And these first 3 chapters talk about a lot of the concepts that we've covered today. And if you're stuck on something like collision detection, there's a good chapter here for that. Or if you just want to see some more examples, he's got source code for things like Snake Game, or Pac-Man, or even Space Invaders. Alright, so good luck on building what's probably your first video game. Hopefully you've got a lot of ideas and some sense for how you might accomplish them. I really tried to strip this project down and make it as simple for you to modify as possible. And if you've finished your project and you're wondering what's next, first of all, I'm super proud of you. You've accomplished something that most people will only ever dream of. The next step would be to just create another game and maybe push yourself to be a little more ambitious the second time around. And then after that, you'll be ready to graduate to a proper game development library. And I've never used any of these Java game libraries, so I can't really give you any recommendations there. But let me know if you end up finding one that you like, and maybe I can talk about it in a future video. As always, I appreciate all the comments and likes, and I'll see you next time.